Welcome to another episode of Math Amazing, where math becomes amazing.
In our previous video, we had a tutorial about logarithmic and exponential functions.
And for today's video, we will teach you how to solve exponential growth and exponential decay involving real-life scenarios.
So stay tuned,
Sit back
and relax.
Exponential growth. Exponential growth is exhibited when the growth rate of the value of a mathematical function is proportional to the function's current value, resulting in its growth with time being an exponential function.
A biologist is researching for a newly discovered species of bacteria. At time t equals 0, he puts 100 bacteria into what he has determined to be a favorable growth medium. 6 hours later, he measures 450 bacteria. Assuming exponential growth, what is the growth constant key for the bacteria?
For exponential growth, we use the function a of t equals p times e to the power of kt. So the variable p stands for the initial amount of bacteria. The variable e stands for the constant in the natural logarithm. The variable k stands for the growth constant. And the variable t stands for the amount of time. So, the initial amount of bacteria is 100 in time 0. So, a of 0 equals 100. It is also stated that after 6 hours, the amount of bacteria is 450. So, a of 6 equals 450. Using the formula for exponential growth, we substitute the value of a of 6, so the formula for this exponential growth is a of t equals p times e to the power of kt.
We substitute the value of a of 6. A of 6 equals p, which is 100, times e to the power of k, and t, which is 6. A of 6 is equals to 450. 450 is equals to 100 times e to the power of k, 6. Isolate the variable k. We divide 100 on both sides. So it becomes 4.5 equals a to the power of 6k. Multiply both sides by ln, so ln 4.5 is equal to ln e to the power of 6k. Using the power rule, it will become ln 4.5 is equal to 6k times ln of e. And since ln of e is equal to 1, we don't mind this. Divide both sides by 6 to isolate k, and we now have ln 4.5 over 6 is equal to k using the calculator. K is equal to 0.25. The growth constant in our problem is 0.25.
Exponential decay. Exponential decay is generally applied to word problems that involve financial applications, as well as those that deal with radioactive decay, medicine dosages, and population decline. To decay exponentially means that the topic being studied is decreasing in proportion to the amount that was previously present. When doctors prescribe medicine, they must consider how much the drug's effectiveness will decrease as time passes. If each hour a drug is only 95% as effective as the previous hour, at some point the patient will not be receiving enough medicine and must be given another dose. If the initial dose was 250 mg and the drug was administered 3 hours ago, how long will it take for the initial dose to reach a dangerously low level of 52 mg?
For exponential decay, we use the formula a of t to A sub 0 times 1 minus R to the power of t, wherein A of t is equal to the amount of medicine after time has, and A sub 0 is the initial amount of medicine, and R is equal to the rate of decay, and t is the time. Now we will substitute the known values for the variables. So the amount of drug left after time has passed will be 52 milligrams. The initial dose is 250 milligrams. It is stated in the problem that the drug's effectiveness will only be 95% as effective as the previous R. So the rate of decay is 100% minus 95%. So the rate of decay is 5%. And for T, we are looking how long will it take for the initial dose to reach a dangerously low level of 52 milligrams. So we are looking for number of hours. Next, we will substitute these values to the equation. So it will become A of t, which is 52, is equal to A of 0, which is 250, times 1 minus R, which is 5%, which is also equivalent to 0.05, to the power of t. So this is our equation now. And now we will solve for the value of t. So 52, 250, 1 minus 0.05 is 0.95 to the power of t. And we divide both sides by 250. 52 divided by 250 is equal to 0.208. 250 divided by 250 is equal to 1. There's no need to write 1 in the equation. And then we take the logarithm of both sides. So it will become log of 0.20 equal to log of 0.95. And by the power rule, we will move this exponent here to become a coefficient. And then we divide both sides by the logarithm of 0.95 in order to isolate t. Next, we use the calculator to solve for this. So, logarithm of base of 10 of 0.208 and logarithm base of 10 of 0.95 is equal to 30.61. Our time is 30.61. Therefore, the time it will take for the drug to reach a dangerously low level of 52 mg is 30.61 hours.